So the Cancer Prevention Study 2 is within the long history that the American Cancer Society has of investing in data resources that really help to better understand what causes cancer and how to prevent it. So the Cancer Prevention Study 2 is about 184,000 men and women who were recruited in 1992 to be followed for over 20 years to see who gets cancer and who doesn't. At the time that they were enrolled, they provided questionnaire information about their lifestyle, their medical factors, as well as their diet. And that information has been updated through questionnaires every 2 years for these participants. And we also we also link their names and information to state cancer registries, as well as the National Death Index, so that we can really relate the information about different exposures to who gets cancer and who doesn't, to again identify the risk factors for different types of cancer. So in particular, women who are diagnosed with breast cancer, at the time they're diagnosed, we ask them if we can go back and get both their medical record as well as some of their tissue specimens at the hospitals. And so this project with Slalom relied on that tumor tissue. So the tumor tissue that we get from the hospital also includes these slides that have been stained so that the pathologist can make a diagnosis of breast cancer based on looking at the different cells in this slide and how those cells are arranged and how they look. And so, but we knew that there were additional clues in this slide that we could utilize to better understand both what causes breast cancer as well as what the different characteristics of this tissue is to see who dies of their breast cancer and who doesn't. And when we were approached by Slalom and all of their machine learning expertise, then we applied that to a digital image of these slides to look for unique patterns that a pathologist wouldn't necessarily be able to identify. And then we utilize those different patterns together with the information that the American Cancer Society has collected over time on these women since 1992. So I belong to a team of 60 people, in which a large majority of them are really responsible for collecting these different data, as well as the tissue specimens from the hospital. And it is time consuming, and certainly we want to garner as much information from all of these different data sources that we possibly can. And that's where I think machine learning really, we have a lot of potential to further understand what causes cancer using these new approaches. So these slides are made by different hospitals across the U.S., starting in 1992 through about 2015. And so there's been a lot of changes in how these tissue specimens were prepared and how they were stained, as well as these slides have been well used by clinicians and have circled different areas. And so one of the first steps in our project was really dealing with these artifacts before we could load them into a machine learning algorithm. And so Slalom worked with us to identify all the different artifacts and to be able to color normalize, et cetera, to minimize the artifacts. Yes, so the machine learning algorithm identified 100 different patterns. Some of those, it was reassuring to know that they do seem to be picking up on aspects of the tumor tissue that we know about. So one of those is about how the different DNA, how they arrange themselves in cancer cells versus non-cancer cells. And so it seems one of the patterns is depicting that, as well as other patterns look like they're picking up on the fat cells that we know exist in these breast tissue samples. But as well, there were other patterns that we really couldn't put any sort of our standard clinical terms to, but we expected that because that is the benefit of the unsupervised approach, that it really is identifying things that we had no clue that they existed.